Welcome to a complete course in calculus. This is Tadessa. So in this video, we'll see some examples of finding derivative from given expression, just like what you see here, or from a graph, something like this, okay? So let's start with the first example. The first example says, given a function f of x equal to negative 5x divided by square root of 2x minus 1, we want to find or determine the point where this function has a horizontal tangent line. So we know that the slope of a tangent line, is nothing but the derivative at the point of tangency. So if the graph, the line touches the graph at c comma f of c, the slope of that tangent line is given by the derivative evaluated at c. So in our case, it has a horizontal tangent line, means the slope must be what? 0. So basically, we want to find c such that f prime at c equal to 0. So first, I need to find the derivative of f. So how do I find the derivative of f? Derivative of f will be, I have to use quotient rule. So what is quotient rule? Quotient rule says if you have a numerator divided by a denominator, division, so its derivative becomes n derivative times the denominator minus n of x times the derivative of the denominator divided by the denominator square. That's what we call it, quotient rule. So let's do that. So in our case, n of x is negative 5x. So its derivative becomes what? Negative 5. And radical 2x minus 1 means nothing but 2x minus 1 to the power of 1/2. That's what it means. Okay? So this is equal to this. So its derivative becomes, now I have to use chain rule for that. So chain rule, or we call it in particular the general power rule. So it will be half times 2x minus 1 to the power of half minus 1 times, this is minus, times the derivative of the inside, which is 2. So now the 2 cancels out. So what's left? 2x minus 1 to the power of half minus 1 is negative half. So this is a negative exponent. It can be written as what? 1 over 2x minus 1 to the power of half, which is equal to, this is equal to 1 over radical of 2x minus 1. So what that means? We have the derivative of the numerator, we have the derivative of the denominator. So I can plug in these values in the quotient rule. So it becomes f prime at x equal to the derivative of the numerator, which is negative 5, times the denominator, which is square root of 2x minus 1, minus the numerator, which is negative 5x, times the derivative of the denominator, which is radical 2x minus 1. Everything divided by what? Radical 2x minus 1, the whole square. Now let's simplify that. Now you can see here I have radical 2x minus 1 in the denominator. So to simplify, I will multiply this guy by radical 2x minus 1. This is nothing but finding a common denominator. So it becomes negative 5. Radical 2x minus 1 times radical 2x minus 1 is 2x minus 1. Minus with minus becomes plus 5x. That will be divided by radical 2x minus 1. Now everything will be divided by this. Now radical 2x minus 1 square is 2x minus 1. Now I'll be using this. A over b divided by c becomes a over bc. So this will give me minus 5 times 2x is minus 10x plus 5 plus 5x divided by, now 2x minus 1 times radical of 2x minus 1 is, they have the same base, right? So the same base means, just think of it like this guy, 2x minus 1 to the power of 1 times 2x minus 1 to the power of half. If they have the same base, multiply means we add the exponent. Half plus 1/2 becomes 3/2. So this is nothing but, if you want, this is rational exponent notation. If you want to write it using radical notation, it will be square root of 2x minus 1 cube. So in the denominator here, I will have square root of 2x minus 1 cube. So if you simplify the numerator, minus 10x plus 5x is negative 5x plus 5 divided by square root of 2x minus 1 cube. So this is nothing but the derivative. Now, we want to solve really the derivative at a point C equal to 0. It doesn't matter if you see x, okay? So this guy equal to 0, the derivative equal to 0. Why 0? Because it is horizontal tangent line. Now, again, if you have a fraction a over b equal to 0, if a fraction is 0, the only possibility is what? The numerator must be 0. So which means in this fraction, if this fraction is 0, which means negative 5x plus 5 must be what? 0. So this is a linear equation. You know, add 5x or subtract 5 from both sides, whatever you want. So the value of x will be what? 1. So x is 1. So 1 comma f of 1. This is, I want to find the point where the horizontal tangent line touches the graph of f. So this is the x value, the y value is f at 1. So this is 1 comma, if you plug 1 here, in the original function, it's negative 5 times negative 5 times 1 divided by square root of 2 times 1 minus 1. So this is 1 comma 2 times 1 is 2, 2 minus 1 is 1, square root of 1 is 1. So negative 5 times 1 is negative 5. So this is the point where this function will have horizontal tangent line. Good. Let's say to the next example. The next example says you are given the graph of f and g, and I gave you some points. You'll see, you know, why I wrote these points. You may be given like that, or you should be able to read from the graph. So now the question is, let's say you have a function, two functions, s of x, which is nothing but the composition of g and f, and h is the composition of f and g. We want to find s prime at 9 and h prime at 3. Let's start with s prime at 9. So what is s prime at 9 means? Oh, because s of x is the composition g of f of x, s prime at x becomes what? Chain rule, g prime at f of x times f prime at x. That's what it means, s prime at x. In particular here, we want to find s prime at 9. S prime at 9 means what? G prime at f of 9, my x, times f prime at 9. Okay, so g prime, oops, g prime at, now, of course, you don't see the value of f at 9, but let me give you what the value of f at 9 is. I know this graph is a little bit, this should be a little bit shifted to something like this instead of this one. But anyways, let me give you the value. The value of f at 9 will be 9 comma 8. Okay, this is given. Okay, all these points are given. I'm reading from the graph. So which means f at 9 is 8. So I'll just plug 8 times f prime at 9. Now the question is, where do I find the derivative of g at 8 and the derivative of f at 9? The answer is derivative means slope of the graph of f, or slope of the tangent line to that graph. In our case, each piece here, whatever you see here, is their line. So their line means you need to find the slope of that line. That will give you what? Exactly this guy. So for example, let's see g. G prime at 8 means what? The slope of that line at 8. So at 8, if you see these 2 points, at 6 I gave you, let's see if I do have that, because 8 is somewhere here, right? So we need just some kind of information about this. So let me give you this joint point here is 6 comma 5, that is given, okay? And then another point what I can pick is I would say 10 comma 1, okay? So this point is 10 comma 1. So I have to find the slope of this line, this here, whatever you see here, which is 6, 5, and 10, 1. So that is what the derivative at 8 means. This at this point means it's nothing but the slope of that line. So how do I find the slope? So for the slope of this guy, I will say 1 minus 5 divided by this 1 minus 5 divided by 10 minus 6. So this is what the slope is going to look like for this one. And the second one, f prime, again, you know, f prime at 9 means somewhere 9 is here, 9 is here. So I have to find the slope of this line. So this is 6, 2. Let me give you another point here, which is, I would say, from the graph, I can read that 10, 10. So that will give me what? So 10 minus 2, right? 10 minus 2. So this is 10 minus 2 divided by 10 minus 6, right? 10 minus 6. So 10 minus 6. So this will give me what? This is the derivative at 9. So 1 minus 5 is negative 4 over 10 minus 6 is 4 times 10 minus 2 is 8. 10 minus 6 is 4. So this is negative 1. That guy is, you see, this is the slope. G derivative at 8 means not the slope of the graph of G at 8, which is, because it's a line, that is what the slope is, 8 over 4, 2. This is what exactly we did now. Now negative 1 times 2 is what? Negative 2. So this negative 2 is what? The derivative of S at 9. S is nothing but the composition. So similarly, for H of X, which is equal to, you can see here, H, it says H is nothing but the composition. So H prime at X is F prime at G of X times G prime at X. So in particular, we want to find at 3, right? H prime at 3 is F prime at G of 3 times G prime at 3. So F prime at G of 3. What is G of 3? Okay, so let me erase this guy. F prime at G of 3. What is the value of G? G is here. The blue one here you see is G. At 3, the value is, this is 3, right? So the value of G at 3 is given to be, the value of G at 3 is given to be from, I'm reading from the graph, it is 5, okay? So it is 5. G of 3 at 3, it is 5, okay? It's given at 5 times G prime at 3. G prime at 3 means nothing but, again, I have to find the slope of the line at, the slope of tangent line at 3, or the slope of the graph of G at 3. Now let's see. You see, in the case of F, where is 5? 5 is somewhere here, right? So, which means I am referring to, if you think of this 5, I'm referring to this line. So this line means I'm gonna take 6 to end to 0. So that will give me this guy, right? F prime at 5, which is 2 minus 0 divided by 6 minus 2. Okay? Times G prime at 3. So G prime at 3 means, again, you know, the 3 is somewhere here, right? So I am referring to, if you see here, I'm referring to this line, right? So this line means I'll take 4, 6, and 2, 4. 4, 6, and 2, 4. So 6 minus 4. 6 minus 4 divided by 6 minus 4 divided by 4 minus 2. So if you simplify that, it will give you 2 divided by 4 times 2 divided by 2. So which means the slope of F at 5 will be half, and then the other guy will be 1. So the answer is what? 1/2. That's how you find derivatives of a composite function if you are given the pieces that form the composition. Thank you for watching. I'll see you in the next video.